Welcome! Now we are going to set up and go through our first TIG stack for installation on your own computer. And the TIG stack is a stack for Telegraph, Influx and Grafana. So it's a couple of open source tools that you can use to both store, collect and visualize your data, and also alerting. Influx is a Timeseries database. Telegraph is the tool you use for collecting the data, and Grafana, a really nice tool which you are going to use for visualizing your data, plotting the data. And Grafana is what you're actually going to see, but the other tools are, like, say, in the background. So we're going to set up this using Docker and Dockercompose. Just to show this is a general picture taken from the Influx Telegraph homepage, and usually this is used for also collecting and storing data from a server, so CPU, RAM, load, network activity, etc., which is collected by Telegraph. But it doesn't have to be CPU RAM. In this case, we're going to use this to collect IoT data from our devices, and that could be whatever. And then we store this in a database, Influx database, and Grafana fetches that data from the database and visualizes that. So this is how this is going to work. And short, a time series database, it's when you store things with the timestamp as the meaningful component of the data. That's the index will be a timestamp. So just a classical example is like a stock currency exchange price data, but we often store IoT sensors logged in a time series database. So Telegraph, that's the collection agent. That's the program that collects the data, that fetches the data and puts it in the database. There are a lot of services that you can configure Telegraph to collect data from. So it's a really powerful tool. Influx, that's the database. If you want to get a little bit more insight on Influx database, there is a lot of nice documentation out there. I have a linked pretty good introduction article of what time series databases, and also especially more about Influx database. It's a very similar language to SQL, so it's easy to get going. And in this exercise, you won't have to write a single line of database code. It will all be taken care of by Grafana. So Grafana, that's what we're going to plot the data in. So it's for the visualization and also monitoring and analysis. You can do some data transformation, and that's where you're going to create the dashboards. You can create as many dashboards as you like. You have as many choices as you would ever think of. And there is a lot of plugins you can explore later on. So this is how it's going to be looking after we are done here. And as I said, we're going to use Docker. So what you need to do first is to install Docker. And Docker is a really nice way of installing a container, which is essentially a program, but it's pre-configured with all essential repository that's needed, and etc. So if you have a program and you want to distribute and run that on different operating systems, Docker is a nice way of doing that. So you need to install this. It can be done on most operating systems, and even single board computers like Raspberry Pi. So just head over to the install Docker page. If you're on a desktop operating system, Dockercompose is included as part of these installs, so you don't have to care about that. If you're on a Linux system, you need to install Dockercompose manually, but it's very easy. But you need to install that. Obviously, I've already installed Docker. You have to do that yourself. The images we are going to use are Telegraph, Influx, and Grafana. You don't have to pull this in before. It will be automatically pulled when you run the compose script the first time. But if you want to pull them in advanced, it might go faster when you run your compose script, and also if you want to update the images. So Dockercompose, and Dockercompose is a way of starting multiple Docker applications at once. So instead of starting the Telegraph installation and configuring that, and also starting the Grafana and the Influx, then we would have to do a lot of different commands and configure them individually, and that takes time. And also, if I want to reproduce this, as I do in this case, I want you to be able to run this very fast and just get it going. You can write a script which is stored in a configuration file called Dockercompose. So this is how this Dockercompose file looks for this example. And essentially, this is just a recipe for starting 3 different Docker containers. So the image used here is the Influx. I'm using the ports. I'm defining here the configuration for the Docker container. I want it to have the authentication enabled. So, and it also creates, if you have no data, if you've never done this before, when you run this for the first time, it will automatically create a database called IoT with the admin credentials, IoT, LNU, and MicroPython. And I'm mapping the local folder data InfluxDB to the path inside the container var lib InfluxDB. That means that the database in this Dockercompose file will be outside the container. It will be on your local file system. So you don't have to do it this way, but if you don't do this and you remove the container, you will lose all the data. Another way of doing it is creating a container which you can store the data in. Then Grafana, same here. We're opening the ports 3000, creating an admin user, just the standard, and the same thing for Telegraph here, some settings. Just note here that the Telegraph configuration file is linked, so that you can find the Telegraph configuration file in here. And you will find this in our GitHub page. So at GitHub IoT LNU applied IoT 20, you'll find this in the repository. So the Telegraph configuration, and there is an example file, but essentially what you need is the Dockercompose and the Telegraph conf. That's about it. And download this and put it in a folder. And the folder called data, that will be automatically created. If you're on a Linux system, just make sure that when you put your folder that the Docker service has right permissions in that folder, otherwise it will fail. I've created in this configuration file for Telegraph, I've created 2 different sources. One source is the TTN, and it's a general MQTT consumer. It's already pre-configured here for my account. This application and password, well, obviously should not be shared, but for this purpose it doesn't matter because I'm going to remove it later on. But you'll find this if you go into your the Things Networks console, press your application and application ID. That's what you put here. And the key. That's what you put here as password. And the data format is JSON. And I've put yet another MQTT source. I've created for this course an MQTT server which you all can access. There are many public MQTT brokers out there. You can use any of them. But this one is at least password protected, even though I'm sharing the password now. But if you use an open public broker like Hive MQTT or something like that, just remember your data will be readable by everyone in the whole world that reads the same topic. Or you can start up your own broker on your machine. We won't do that today, but that's also something. And this is the topics that we're following. So in this case, I will be getting all my devices which are under this application. And in this case, I'm subscribing to a topic called devices. And the username and password I've set for this server. It's IoT-LNU and MicroPython. And then the output from the Telegraph is configuration. That's InfluxDB. So actually this host name is defined in the file, the compose file. So InfluxDB is that host name within this container is linked to InfluxDB. So you have to, well, don't change that, they won't find each other. The same, the username is set as well. You can change this to whatever you like, obviously, but it should work out of the box. So this is how we're going to configure Telegraph, and well, obviously I've already done that, and as you see, I've already configured the username for my TTN instance and the password. And as it is now, there's really no meaning of starting up our TIG stack and trying to get things into that. You need to have something that is pushing data. Well, it's a pre-recorded video, so obviously I have something prepared. And as you can see here, I have my very advanced looking messy sensor here. And this is a CCS 811 air quality sensor. This is a BMP 180 pressure and temperature sensor. And this is a DHT22 temperature and humidity sensor. All is connected to a LoPy4. Yeah, and the code for this example is found if you just go to our GitHub page. You'll find all the code. And just to note here that, well, if we send the data in a JSON object, it will be treated correct when fetched by Telegraph as we configured it as a JSON format. And that's a pretty good and standard format to be working with. So let's look at this program. And you can find the code online, but what I'm doing here is that in this example, this sensor is connected with Wi-Fi. So not over LoRa. This sensor is now connected with Wi-Fi. I'm using the MQTT, MicroPython MQTT library. And in essence, I am reading all these values, CO2, VOC, BMP sensor pressure and temperature and DHT and relative humidity. And then I'm publishing this under the name office sensor, and then the values are in an object under that office sensor. This is standard JSON format to the topic pub, and the topic publish topic is found here, devices office sense. And well, this is actually working now. Even though I haven't even started my TIG stack, the MQTT server is up and running, and my sensor is publishing its data to the MQTT server. So what we could do is to just download a program called MQTT Explorer. I can recommend this program. It's pretty nice. There are a lot of different MQTT Explorers. You can find an iPhone app or Android app as well. There are even these MQTT clients that you can run in the web browser, or you can do it in the terminal. But now I'm just going to connect to my MQTT broker, and that's holab.lnu.se. The password is micropython and IoT-LNU. I'll press connect, and voila, I'm connected. And here we can see that something happened. I had a short misconnection here with my sensors. So if the LED doesn't blink, it's not sending. So let's start again, and I'll manually start the thread, sending for each 10 seconds. So we'll push some data through. You can see that the LED is blinking every time it's sending. And let's see, it should be blinking anytime now. And there we had a blink and some sending done. And you can see here in the MQTT Explorer that data is being transmitted. Something happens. And this program is pretty nice. So I can actually plot inside this program. Which is a nice thing. So it's a nice way of seeing what happens if you subscribe to MQTT topic, and you can also publish data within this program. But okay, it seems to be working. At least I get some data from my device up to the MQTT server. That's all I wanted. Let's just keep that running and install the TIG stack. And I'm already in the right folder, so just download the folder with the configuration files, install Dockercompose and Docker. Then it should be as simple as run Dockercompose up. And in this case, when I only run Dockercompose up, I will run it directly in the terminal. If you want it to run demonized, that's, well, in the background, you should just add a D after. So let's see how this works. Now it's creating 3 different containers. And you can see all the output here from creating these containers for the first time. And now, the first time when we're creating these containers, there is no data at all, so Grafana here is executing and installing a lot of plugins. Influx database is created, and etc. So there will be a little bit of waiting before you can start seeing what happens. But you can see here that I got a message from the Influx database. Right here in the database IoT, something seems to be happening. Oh, that's great. Okay, it seems to be doing something every 10 seconds. I wonder why. Okay, but the interesting thing here, now I've created my TIG stack, and as long as your configuration is correct, and in this case it seems to be more or less correct. I haven't gone through all the full log, but at least it started. And it seems that it's writing something into my database every 10 seconds. And well, I could see that the MQTT server also, well, I saw some data in there for every 10 seconds. So what you should do now is the most exciting part of this journey. You should fire up Grafana, which is now hosted on your computer, along with Telegraph and Influx. But those are nothing that you, well, as long as they work, you will not have to care about them. And this is the first time we're firing it up. It's your local address. You could write local HTTP, localhost, and then port 3000, just to be sure, and then log in. First time you fire this up, it's admin. That's the standard name. I'll just skip of changing this. And what we should do now is to add your first data source. We need to add the Influx database to Grafana. So I'll just do that. I can do it from here, or I can go up and go to configuration and data sources. But I'll press the welcome guide. And then I'll press the Influx database. There are more databases I can choose from, but in this instance, we're running Influx, so which, well, you're probably already aware of. I'll need to write the address of the database, and that's InfluxDB, :8086, port 8086. So that's the address to that other container. And then the database which we started up was IoT. You can have several databases and several data sources. And the user is IoT LNU, and the password I created is micropython, as you saw in the configuration. And then press save and test. And oh, it flashes green. Data source is working. Great. That's all I need for now. I'll just go and create a new dashboard, and I'll add a new panel. And this is where the fun starts, because if everything works now, you should have some data in your database. But let's see. Select measurements. Oh, I have something here. Wholab. That sounds interesting. And if you remember from the configuration file, that's where the MQTT server, that's the MQTT server. Where, and I can show, take a tag here, either host or topic. I choose topic, and devices office sense. That's the topic on the MQTT server. And then I can choose a value, and I want to plot the CE2. Okay, something happens here, and I can take the mean value, etc. You can play around with this later on. I want to fill everything in line with the liner, so all dots have a liner interpolation in between. I can change the line width and etc, etc, etc. There's a lot of things I can do here, but just let's keep it like this. I'll press apply, and then I'll take just the last 5 minutes, and I can auto update this to 10 seconds. My first Telegraph, Influx and Grafana database up and running. It's not that hard, and just note that this is now running on your computer. It will, if you demonize it, it will run in the background, obviously as long as you have the Docker service running. Usually this is, well, not the recommended way of doing this. You should probably run this on a server. So if you have a server, you could be running this instance on a server, so it's up all time, not only when you have your computer running. But now you have a very advanced and cool tool to play with for plotting your IoT data. So thank you for watching. I hope you learned something during the way, and just let me know if you have any suggestions on how to do this even better. Thank you.